Well, hi there, ladies and gentlemen. Welcome back to another video from the JSsifu channel. So today we are going to solve an algorithm question, two sums. This is one of the easy ones that you will encounter if you ever interview in a software engineering world somewhere. Probably they will ask you this question for the phone interview. This question is also coming from Leetcode. I think it's the first question they ever post on Leetcode. Yeah, like I said, it's a really classical question. Make sure you know how to answer this question if you're ever running into this question in any interview setting. Okay, let's take a look at the requirement for this algorithm question. So you're given an array of integers, let's say nums, and the target integer, right, 9. And you want to return the indexes of the two numbers such that they add up to the target. So for this array, 2, 7, 11, 15, 2 and 7 would add up to 9, right? And you want to return the indexes of 2 and 7, which is 0 and 1, okay? All right. So the assumption you can make for this question is that you may assume that each input would have exactly one solution. So this is what makes it really easy, right? You may not use the same element twice. Okay, so let's say for example, if we have a number 4.5, oh no, sorry, is that 4 point? Yeah, 4.5. 4.5, you cannot use 4.5 twice to add up to the target 9. Okay, so that's the one of the assumptions. And you can return the answer in any order. Okay, so you can either have 0 and 1 or 1 and 0. So either case, you will pass. So we're going to solve this problem in two ways. First, I'll show you a very naive approach using the brute force approach to solve this problem. And the time complexity is going to be O(n) squared. It's not the optimal solution, but I'm going to show you this version first, and then I will show you an optimal solution using hash table. Okay, so let's go on and use the brute force approach. Kabam! This is the code. So let's look at what I am doing here inside this brute force approach. I define a function called toSums, and it takes in two arguments, right? The nums, the array, and then target and integer. Okay. And for this one, I'm going to loop through each element in the the nums array, and then with I equals 0 and I less than sum start length. So this is the really easy for loop. Okay, so nums 0, right, is 2. Okay, but inside here we'll have another for loop, right? The for loop, it goes to the next element. So we're going to loop through 7 to 15. So after you loop, you have select the element 2 inside this outer loop. You're going to loop through again the array itself from the index after the index you have selected. Okay, so the index selects on the first time iteration we have 2, so I equals 0, right, as index 0, and then in the inner loop we have loop to again from 7 to 15. So we have j equal to I plus 1, right? So index j is going to be point to the element after 2, which is 7, right here. Okay, so we will loop through it, and then we will have if the number, right, nums I, which is 0 right now, plus num j, which is 7, if it's equal to the target, then we will know that this two number is the indexes I need to return to for the function. So we'll return I and j inside an array, or can use j or I. It's because the order doesn't matter, right? So let's take a look at the test case right here. So we have test case 1, num1 equal to 2, 7, 11, 15. Target is 9, right? And then we cancel out the result of two sums with num1 as input as an array and target 1 as a target. Okay, so in my console, I'm going to say node to sum, and you can see that we're returning 0 and 1 inside the array, which is the index that we need to see as a result of this question. We need to see 2 and 7 that adds up to 9. Right? This 0 and 1 is the index for 2 and 7. All right, let's try another test case. Let's say we have a test case 2 right here. Now we have a whole bunch more number this time, right? So we have 5, 6, negative 2, 1, 6, 100, 200. And the target we need is 201. Okay, by just looking with our naked eyes, we can see that 201 is the only solution to this problem with this test case. All right, so it should return, so 0, 1, 2, 3, index 3, and 4, 5, 6. Okay, so 3 and 6 is what we need to return. Let's try it out. And that's exactly what we needed. So let's talk about the time complexity of this approach. All right, I already tell you about this one. Is going to be the brute force approach, which has a time complexity of O(n) squared. Right, and the n is going to be the length of the nums array. All right, and this is not the optimal solution to solve this problem, because if you go into an interview for software engineer and this is the solution you give them, then they're probably going to have a follow-up question to ask you, how do you improve the speed for this function, for toSum? All right. And next, I'm going to show you how to improve the speed using hash table. And bam, this is the solution for the hash table implementation for this question. All right, we have the same function, and then inside here, we define a hash table or an object in JavaScript world called scene. So what this scene object is doing is to keep track of the number we have seen inside the array. Then we gotta compare on each element that we're going through to check if what we have seen and the current element that we are in that adds up to the target. It will be easier if I walk through one example with you, right? I'm going to use the test case number 1, 2, 7, 11, 15. Okay. So what we're going to have to do is the first element is 2, right? So what's 2 here? What is the first element? So first iteration in the inside this for loop right here. Okay. So we will check if target 9 minus 2 is inside scene. All right. If not, well, first we know that the scene right now is an empty object. So this, on the first iteration, this is a falsy evaluation, right? This is a falsy. So nothing's gonna happen here. Right? We do nothing here on the first iteration when I is equal to 0. So then we will add to the scene object on the hash table scene of nums I, nums 0, right, which is also equal to 2, and set it equal to the index. So on the first iteration, we're going to have 2, and then we'll set it to the index of it, which is 0. Okay? So this is what we have after the first iteration. Okay, now let's look at the second iteration when I is equal to 1. When I is equal to 1, and remember this is our second iteration, right? We already have something inside the scene object. Okay, so when I is equal to 1, let's look at what happened inside here if in the loop statement. So we can check is target 9 minus nums are 1, right? Y is equal to 1. So nums 1 is 7. So 9 minus 7 is what? Is equal to 2. Now we check if this 2 is inside the scene object. If it is, then immediately we're going to return the value of 2, right? Because we're going to return an array, right, as our final solution. Scene target minus 1, target minus nums 1, I, which is equal to, sorry, this thing evaluates to 0, because target minus num 1, right, 9 minus 7 is equal to 2. Scene, the object, has 2 inside, and it points to, it has a value of 0. So this evaluates to 0, which is the index we want for that number, right? We want an index number for 2 in this array. That's what we have in our dictionary or hash table. And we also want to return the current number index. Our current index is at 1, right? Because we know 7, right? We are on 7, this the second iteration, which has index of 1. So there you go. We have 0 and 1. All right? And that's it. Once you return something, it breaks off the loop. It jumps out from the loop, and then it just returns the whatever value you have. Okay, let's try that in the test cases. All right. So we're gonna run the test case for the first test case. Right, those are what we did before. Target 9. We're expecting to see 0 and 1 here. Okay, so I'm gonna go to my console, and boom, we have it. 0 and 1. Let's look at our second test case as well, just to make sure. Oh, hold on. Oh, then say, okay, here you go. All right, here you go. We have 3 and 6 as we expected, just like the first test case. Just as we expected from the first solution, right? Well, in case some of you guys are still confused about this solution with hash table, I'm going to go over the function again with the second test case, which we have right here. All right, let's make this a little bigger. Here we go. Okay, so now initially in our function, scene is an empty object, right? So we have scene equal to empty object right here. And then we're going to loop to each element in the array. So it begins with I equals 0, right? I equals 0, nums I is equal to 5, right? Nums 0 is equal to 5. So we're going to check this condition, right? Is target, which is 201, minus 5 in this object. Oh, our object is empty now, so this is falsy. Okay, now we're going to add this number 5 into our object or hash table, and then we're going to assign it to the index, right, which is 0. I is equal to 0. Okay, so this is our first iteration. Okay, now the second iteration. So this iteration is done. So let's go to the next iteration. I equals 1. When I is equal to 1, we check again, right? Nums I or nums 1 is equal to 6, right? So we check is 200 minus 6, which is 195. Yeah, 195 is inside this object. Of course not. Then this is a false statement. Then we're gonna go here. All right. So we're gonna put this 6, just like the first one, we're gonna assign it to its index. All right, what's gonna happen now? So 2, -2, same thing as the first 2 iteration, because 201 minus -2, which is +2, 203, is not in the list we have here. All right, and we assign the index to it. All right, you see what's happening here? -2, which is right, nums2, and target is 201 minus -2 is not in scene. The scene we are checking in here that only 5 and 6 is in there as a key, right? We always check the key. In our case, we always look for the key in our object here, or hash table, okay? And accessing any key from here is just a single operation, okay? It's constant, so it's really fast, all right? Okay, so let's go to the next index. We have index 3, but a number with 1. So nums3 is equal to 1, and then target is 201 minus 1 is 200. Is 200 in our hash table? No. So then we will add, all right, we'll assign the key to our hash table, 1, right? Oh, can't type. And then we assign the index of it to the number. Okay, so we have 1 and 3. Next index, index 4, and then the number is 6. Okay, so is 201 minus 6, which is 195, in this object? No, 195 is not in this object. Okay, then we will add the number 6, right, and the index of it to the scene object. All right, next element, 100. All right, the index is 5. And we'll say is 201 minus 100 inside the scene table? And the answer is no. So we will keep going to add this to the key. All right, again, the key is the number itself, and the index is going to be 5. Okay, here is the final element, 200. And here is where the magic happens here. All right, so the index for 200 is 6, right? And then we'll check if target, which is 201, minus 200, which we solve to 1. So is 1 inside our object here? And yes, 1 is actually here. And it returns index of 3, right? Okay, so if this statement is true, then we're going to return something. All right, so right now our I is equal to 6, right? We are at the last element of this array, so our I is equal to 6. Now we're going to return an array. Remember, our output is always an array of 2 indexes. Now we're going to return, right, the scene target minus nums I. So if I is equal to 6, nums, right, is equal to 200, and target is equal to 201. So 201 minus 200 is 1. So scene with key of 1, you get 3, right? So you get, get 3 as the first element. And look at what we have for I. I is just 6. And that's exactly what we're going to return for this function. And that's exactly what we returned before with our brute force solution, right? And then this is exactly what we want to see, because 1 plus 200 is equal to 201, and they're the only solution that adds up to the target. So let's talk about the time complexity of this approach. All right, so this approach is going to render you a linear time complexity, which means that it's going to be time. It's going to be O of n linear. How so? You say, well, we know that n is equal to the length of the nums array. All right. So this is how we're gonna figure out. You're only looping through the array one time, right? And we are checking the scene hash table, right? We have a hash table here. We're checking this key, the number, in this object every time we loop through it. And to check whatever you have in an object in JavaScript it has a constant time for this operation. Okay. So since we're only looping into one time, and the operation is how many operation you have in there. It could be any so this is one operation. This is one operation. All right. So it's like 2n. But again, the coefficient of any before n is not significant, so we can just discard the 2. So it's going to be O of n. And that is the time complexity of this approach. But you also have to notice that we also have a space complexity of 1. Right? Because we use a hash table. Actually, it's also n because you have, the worst case scenario, we have like all the number listed inside in the hash table. So you kind of have get the worst case scenario, you have like n minus 1 of space inside the object. All right. So in any interview scenario or situation, you want to explain why you want to use this approach, because it's much faster in terms of the time complexity, right? It's O(n) versus O(n) squared. I mean, this is much faster than our previous solution with the brute force. Alright guys, that's it for this video. Thank you so much for watching. If you find this video to be helpful to understand your twosome questions, please like the video, give a thumbs up, and subscribe to my channel if you like. I mean, I have more JavaScript topics to talk about, some algorithms, some of the basic JavaScript and advanced JavaScript topics coming up.